And we have a couple people that want to go early because of time commitments. So Karen, are you around? Yep, right there. We'll start off with you. And please remember, we're no more than 3 minutes. If you can finish in less than 3 minutes, that's fantastic. When you're judging, keep in mind whether people stayed within 3 minutes or not, and if they didn't, you know.
Okay, I promised him 30 seconds. I don't know if I can make that, but it'll be pretty darn close. This is the network time security team. We've been, for those of you who've been around the IETF for a while, we've been working on network time security for a while. Our plan specifically was to improve the status of the implementations. In particular, we were looking for the current draft -12. We have a draft to Scenario NTS, which we were also looking at, which is providing some suggested changes. And we were looking at some interoperability. We did a really good job of remote this time. Actually, we had Team M, which was Martin and his implementation in Germany. We had Daniel's Python implementation, which was here. We had a team in Sweden that was working on an implementation that's in hardware, and then we had some folks from the Network Time Foundation here. And then finally, we had a gentleman who showed up and wanted to work on the Open NTPD implementation, which was very exciting. So on the left is the various team members that we had, and on the right is various pieces, both the documents that we were looking at and also some of the code that was used. These are our 3 teams and the pieces that we had scattered in various places. This is basically what we got done. So you see the draft that it currently is referencing, the language that we were used, and some of the notes associated with it. And finally, this is a chart of what, basically kind of what we learned. And so across the top are some of the server implementations that we have. Down the bottom is the access, the vertical access are the clients. These are some of the pieces that worked and didn't work. The bottom line is that interoperability tests are really important. I guess we all know that. The NOC is very helpful. We actually turned into the problem child for the NOC yesterday, which is generally not my objective. And that Wireshark really helps. So that's about it. It's network time security. I know it's not the newest and greatest, but it is really important, and we would love to have some additional help in the future.
Okay, thank you very much. Mahesh, I believe you're here to talk to us about meth and Yang and
All right, so our plan coming into 102 was to continue the work we had started in 101. In London, we worked on E-line services, and so coming into this, our idea was to work on E-LAN services that MEF defines in their document 6.2 and 10.3. The challenge for us was to keep the project as simple as possible and focus on the implementation of the service itself, and not get bogged down into the network implementation. So to do that, we essentially took 4 switches in a switch network and connected them up so that we could realize the LAN service rather than trying to do this with either an MPLS or EVPN circuit. In trying to implement, we got some headway into getting at least the all port-based LAN service going, which is the EP LAN service. Now, with EVP LAN, we had some challenges, and I'll get into it in a minute. The latest set of code that is there will be updated in this particular GitHub location that's pointed to here. From an architecture perspective, it was trying to move from a point-to-point service to a multi-point to multi-point service. And our decision was to try to replicate the packets closest to the PE node as possible. And links to the test results in the demo will be posted later. So the challenge that I was talking about with configuring a VLAN-based LAN service is the fact that Yang has no way to, Yang allows you to set a value. It doesn't allow you to set a range of values or a set of values. VLANs can be defined in either of one of those formats. So we need a way to be able to specify a range or a set of values, but have to say that from a Yang perspective, it's a nice to have. I don't know how open the idea would be to redo 7950 just for that. From programmatically, you can always have multiple iterations to specify multiple VLANs. So here's a list of team members that worked on it. Most of the team members were remote this time. And I have set some pointers to the specifications that we use for the final models. Thanks.
So next, I'm going to just start going from the top. So I2NSF.
Hello, this is Jian Paul Jung from Chenggang University. The I2NSF framework project this is the fifth time in IETF Hackathon project. This project is for we want to verify the framework of I2NSF and interfaces based on Yang data model like this. And also this time also this is student project, 7 grad students from Chenggang and 2 grad students from Suncheon in Korea, and also 3 professors and 3 researchers in Korea and Japan. So this is the poster for this hackathon. This time we proved the 3 things. The first one is the NetComp support for registration interface for I2NSF framework based on latest capability Yang data model. The second one is I2NSF security policy translation. So translation is very important because high-level policy translated into low-level security policy automatically. Third one is automatic policy provisioning. Given a low-level policy, we match into network security functions to certify required low-level security policy. So this is the first feature, registration interface. You can see the high-level policy given to security controller, it requests the require the NSF, and then the device management system invoke, and then register into security policy, and then we can certify high-level policy using appropriate network security functions. So this is a data model. And also the second one is the security policy translation. So using this box, this is a translator. So high-level policy is in terms of administration over user. That one is translated this procedure. And then low-level security policy is translated like this. So low-level policy is given. This one is decomposed into NSF for byword, and the second one is NSF for web filter. So we can match with low-level security policy into appropriate NSF functions. So this is network configuration. We use the Mininet. So in the middle, we have, you can see security controller for I2 NSF framework. And then we have SDN network, and we have appropriate NSF. So this time we have two applications. One is malicious website the filtering. The second one is malicious email filtering. So we use the open source. So we uploaded the framework source code in the GitHub, so you can access and download our project code. And also we uploaded our demonstration video into YouTube. You can access and then you can check it out. So we learned during this hackathon, we proved the Yang-based registration interface working well to provide automatic security registration. And also the second one is security policy translation, very important for I2 NSF framework. So we proved using our hackathon project. So also we showed based on pure open source, we can make I2 NSF framework. Thank you for your listening. Thank you.
Let's see who's up next. Okay, how about Cusp?
Hello everyone, this is Michael from Huawei, and today I want to present the Hackthon project CASP. Okay, our motivation is to provide that this new protocol, which we defined in the as following links, it can work well and can validate and performance to satisfy the operator's requirement. It can build the separated BNGs architectures. And we want to, here we define two benchmarks. One is to want to verify that the control plane can communicate to the user plane through this new protocols. Another is want to verify that some basic functions that the control plane can synchronize manage the user plane source, and it can dynamic send IP address field to the user plane when a new user die up. After 2 days hard work, we have got some good result, and our remote team help us to set up the environment of the separated BNG, and we hack on this environment. We get good feedback, and we have got the two benchmark as described above. Here is following. This is the demo's topology, and right here is some basic configuration and the session information. And also we use a tester to simulate it. The user die up, and it show here it can work well, and the user die well, and the synchronized control plane can distribute the IP to the user. So this is work well and satisfy that and verify that the new protocols work well, and we believe it maybe can drive the operator's requirement, and maybe it need to standardization. Okay. Here I want to thank our team. We have very large and efficient teams who are hard work and very and give some valuable input and contributions. And especially I want to thank the remote participation team who help us to who have set us a simulated environment. And also I want to mention here is that in China it's very late now, but still online to support us, even though today is World Cup finals. but say don't see it much. Say online support us. I'd like to thank you very much. Okay, I want to mention that we will show our demo in tomorrow's Hackthon Happy Hour. And if you have interest in this topic, please to join us. Thank you.
Great, thank you for the presentation, and thanks for the reminder about the happy hour thing tomorrow. Anyone can participate, but you do have to sign up, and there's the link on the wiki, so you can sign up. And make sure you do that before noon tomorrow if you want to participate. Okay, Lurk.
Hi, my name is Sanjay, and I will be talking about Lurk project, which we started at the last IETF hackathon in London. So just wanted to give an update from where we were to where we are today. Okay. Just to recap, what Lurk is trying to do is to address two key areas. One is basically protecting the security credentials of the security service, and how? By isolating the operations that are associated with the credentials by breaking down into specific cryptographic services. Now, in terms of where we can apply Lurk, we're looking to apply this into a specifically scenario where we can enable the delegation of video sessions such that a commercial CDN can delegate the content to the last mile, such as the ISPs that may be hosting caches where they can download at the same time securely without sharing the private keys. And these are the relevant RFCs that we are working on. Now, in this IETF hackathon, what did we achieve? So we have two running implementations in CLurk and PyLurk. We've also realized that we want to go through the formal verification of the Lurk protocol, so we're doing that. Also the link to the GitHub on different key servers in the PyLurk and the CLurk implementation. What else we did? We also were able to do this ECDHE implementation in PyLurk, and also some updates to the draft, such as disabling the non-secure configurations. What else? What did we learn here? One of the key things that we're looking to do is to be able to integrate with the Nginx OpenSSL, and also looking for the trusted environment as well, implementation there. We also look to implement Lurk extensions for TLS 1.2, full implementation. And also future plans include for us in the next hackathon, we're looking to do formal verification for the TLS, for the extension, for the Lurk extensions in TLS 1.3. These are the members that have contributed to the project. And also a little flow-through diagram, step diagram, and also the use case that you can look at. Thank you.
Let's go next. So, how about we just do that one? So Rift.
No, finally some color. So what did you do? We did something called Rift, which was the first time we had actually a hackathon. Stuff is relatively new. Things went much better than expected, and we got much farther actually. Who was here? About 5 people were hacking code. Bruno, as a free radical, probably the most. A couple of people have shown just no cookies in the company. So what is Rift? So Rift is a new specialized routing protocol just for IP fabrics, especially data centers. It's a mixture of link state and distance vector protocol, if it means anything, so fairly novel. It's completely schema-based, which is kind of, radical for routing protocol in IETF. What did we try to intend to build in this hackathon? We tried to get the Python implementation, the first piece, which is basically adjacency formation, which is quite complicated, in Python to interop it with something which is already available from a vendor. So basically two packages having run into an interoperable test and bring up an adjacency. And then see where we can get farther. So this is basically the output of the adjacency we got up from the Python side. And the interesting thing is it went to three-way, which means we went through the whole finite state machine and exchanged a lot of information and arrived where we wanted it to be. And there's a lot of gory details involved, like all kind of multicast addresses and V6 multicast, all kind of ports being exchanged and so on. So yeah, we had this adjacency within 3 hours. One, because Bruno already did a good amount of work up front. Second, because we found that all this schema-based modeling is actually saving like 80% protocol work that is being done normally, like writing parsers and all kind of quirky code, which is all hand-woven. And the only problem we really found, so the spec seems to have held up pretty well. The only problem we found that we were joining multicast basically on different interfaces, on the laptop, so we didn't see each other. The moment we joined the same interface, the stuff just came up. So we ran out of scope after 3 hours. So then we attacked the next finite state machine, which is far more complicated, and it's basically the finite state machine which allows a complete zero-touch provisioning. So these IP fabrics have this specific property that it is highly desirable that there's simply no configuration whatsoever. They behave, albeit they are doing proper IP forwarding, they're behaving like switches. So you do, V4 over V6 and all the stuff is included, and they have to exchange a lot of information to find where they are topology-wise in the fabric. And there we basically wrote a lot of code, being notably distracted by, the ongoing soccer game. I think that completely killed our productivity for a while. And we ended up, with very serious amount of comments on the models, certain quirks where the model wasn't completely orthogonal, where it wasn't clearly specified, some finite state machine events being better, specified, draft procedures. I mean, the spec is like 70 pages and growing. It's a full routing protocols. It's quite a sizable thing. Yes, actually, we got much more out of this hackathon than we expected. Yep, all done. Thanks.
And how about spin?
Okay, so this is the presentation of the spin. So for those who don't know, the spin bit is a proposed mechanism that will allow a passive observer to do measurements of round-trip time of quick flows by observing in the middle, using a single bit only. So, yep, the relevant drafts are basically all quick drafts. So what we've been focusing on in this hackathon is if we can use heuristics to get more robust measurements using this single bit only, because we have observed problems when there is a lot of packet loss and reordering. So we'll see, can we make this middle box that observes the spin bit more robust and make the code more viable. So what got done was that we took a crappy middle box that we had started implementing last time and improved it so we could handle multiple parallel connections. We implemented new heuristics to reject bad RTD samples. and we also improved our measurement system, so we could include a sequence of netm links where we could apply different impairments and different latencies, especially looking at delay and reordering, so we could try a lot of different conditions. So we learned a couple of interesting things here, that the network impairments have totally different effects on the sort of quality of spin bit measurements depending on where on the path they occur. So if impairments occur below the point of measurement, then they have virtually no effect on the how well the spin bit works. If they're above, they affect the spin bit, and there's where we need to apply our heuristics. We also looked at the effect of the sample frequency, comparing the spin bit sample frequency, which is just once per RTT, with the sample frequency that the server has, which is basically for every ACK. And we could see that it had basically no effect on the RTT estimates. Just some little result we got here is, this is an example of the results we got. This is measuring a 5% reordering happening above the spin bit measurement point. We track here the RTT as observed by the spin bit observer, and the server at full frequency, where the RTT is collected for every ACK, and the server collecting the RTT measurements at the same frequency as the spin bits. And we see that the spin bit measurements here track the RTT very well. So we're really happy with these results. So yeah, we learned that the spin bit rocks.
Okay, we're going back to get some late additions here. So Wishy, do we have folks from that team here? Okay, great.
Hi. So in case you don't know what Wishy is about, this is about light bulbs. And we are trying to work on IoT semantic hypermedia interoperability. And what that means is we have done a lot of work in the last decade creating an IETF stack, and that is being used by a lot of people now. Maybe I should use this. This is used by a lot of people now, and they all have added their own application layer to it. And now we have the next level of interoperability problem. So how do we build a global IoT out of all these parts? And there are already several SDOs out there that have found out that maybe they want to be the glue that binds all the other SDOs together. And so we decided we are going to be the solvent, the thinner that goes into all that glue. So this is essentially what we are trying to do here. So there are lots of existing data models like lightweight M2M and IPSO and OCF and so on. And there are also semantic web technologies that actually turn out to be useful this time. And so we now have several forms of self-description. Ones defined here in the IETF, like RFC 6690, or the thing description that is being done by W3C Web of Things. And we have various forms of directories where self-description information can be stored. And by now we actually have lots of code, but the point is we need to get all this come together. And so what we did this time was lots of infrastructure work. So one of us closed about 40 issues in the Node-Watch implementation. We fixed the resource directory. We integrated with IKEA lights and made thing directories accessible on the cloud, did lightweight M2M, thing description generators, what surveillance, and so on. These are all, it's all alphabet soup if you're not familiar with the technology, so I'm not going to read all of that. So in the end, what we learned is 1.5 days is too short to thin all that glue. So we probably will do more hackathons in online form. Since we're at the application layer, we can easily do that. On the other hand, lots of things are now coming together. So when one of these lights goes on on our table, usually you have about 5 different SDOs working together to make that happen. And this is now happening and starting to work. On the other hand, we also identified, given that we are a research group, we are happy to have identified a number of research topics that will need work to get a more comprehensive solution. If you are interested in that, you can come to the Think to Think research group meeting on Thursday. Thank you.
Okay. You and the next up should be, yep, perfect. Oh yeah, there. Thanks.
All right, who here loves video conferences? Woo! Who here hates surveillance? Yeah. So we can almost give you one of those without the other. All right. We have extreme privacy in this presentation. Yeah. Well, it looks fine on the screen. Let's see if we can just, like, is it visible like that? Yeah. All right, I'm just going to improvise like this. So you may or may not know, whenever you make a video call, voice video call through BlueJeans or WebEx or Jitsi or whatever the conferencing system you're using, the conferencing provider can see everything you're doing and deliver it to whatever intelligence service it's collaborating with, whatever data services it's selling off your metadata to, and all that stuff. Not very private at all. So we've had this working group called PERC to add some privacy to that so that you can have these conferences without the conferencing provider being able to see all that stuff. And so the idea of our hackathon group today was to take some of the drafts that came out of that group, these 3 listed here, and hack them into a bunch of open source products. So libsrtp is very widely used for protecting real-time media. NSS is a library that's used for DTLS and a bunch of key management stuff. Firefox, I assume you've all heard of. And then we hacked up a media distributor and a key distributor, which are some infrastructure bits, one in Go and one in C++ wrapping NSS. So the short answer for what we accomplished here is we made this like whole crazy key dance work. This actually does tell the story of PERC if you sit and stare at it for a while and you're not colorblind. Sorry about that from an inclusion point of view. But basically, there's this whole dance that you go through involving DTLS and SRTP and some extensions to those and passing a bunch of keys and parts of keys around and encrypting things and decrypting things that allow the media distributor, this conferencing server, to do the little bit of modification it needs to do without also getting to see the contents of the packet. So the upshot of that is, you get the conferencing experience you're used to without the need for the conferencing server to see the media, see the actual audio and video you're exchanging. So we got most of this done. We, I think, have audio working. You can do audio conferences through this now with full privacy. There's just something in the operating system that's fragmenting our video packets and causing everything like that. So video is not quite working, but we got kind of audio working and proved out this new architecture. Lessons learned. We're pretty much things work as specified. We found a bunch of clarifications, as you might gather from that previous slide. There's a bunch of complicated slicing and dicing in this key and that key and this half of the key, that half of the key. As long as you keep all those balls in the air and you have them in the right place at the right time, works fine, but we need to clarify and specs a little bit how to do all that. Found a couple minor bugs about which half you use where. And this is all thanks to a team between Cisco and Mozilla folks. bunch of people contributing with different expertises, crypto folks, media folks, that made it all come together. Thank you.
Awesome. Okay. And let's see, where were we? So maybe DNS. I don't know if we have more than one, but this DNS hackathon presentation. Yeah, it's just good. Close. Thank you.
Okay, thank you. So as usual, we had quite a few projects on the go simultaneously in the DNS team. They fell into two real types of categories. One where we were trying to look at real operational issues that are happening in the DNS, and some newer work based around DNS privacy. So one of the projects that we had quite a large team on was a multi-provider DNSSEC project. So today you can do multi-provider DNS, which is great for defending against DDoS attacks, or you can do DNSSEC, which is great for the integrity of your data. What you cannot do today operationally in the DNS is both together. So there's a draft that proposes how you can do this. And the idea behind the draft is that each of the vendors independently sign the zone. There are two models proposed, and they differ in the way that they manage the keys. The work that was done here this weekend was that both of those models were deployed and validated. Interestingly, the first thing that popped up is that some of the diagnostic tools couldn't handle this because they just weren't expecting these configurations. They did develop a minimal API so that the two vendors can synchronize the keys, I beg your pardon, between each other, and some brand new tools were developed so you could check the consistency of the zones that were signed by the separate vendors. So, really nice piece of work. One of the other big operational issues we have in the DNS at the moment is the fact that there is no standard way to have a CNAME in the parent or at the apex of the zone. And we've been having a huge fun fight on the DNS op list about how we solve this problem. You really need a fix. So Andre Suri has a draft that he's proposing. And part of what he did is to actually test what happens today when you put a CNAME and a DNAME both at the parent and at the apex. And what he basically found is you put it at the parent, it mostly works. You put it at the apex, it mostly breaks. So he's collated the information of all the possible issues that you see in both of these cases. And this is going to be really valuable information to feed directly back into DNSOP to figure out how we move forward with a solution to this problem. One of the other projects that got worked on was Oblivious DNS. If you haven't come across this, it's a privacy technique that changes the communication path between a stub client and a recursive resolver by inserting an Oblivious DNS stub in between them. The idea here is that by inserting the stub, neither the stub nor the recursor can see both the client IP address and the content of the query, so no one entity can correlate the two. There was a draft and an existing Golang prototype. What happened here was that the NLNet Lab folks started working on porting that into C. And the first things that came out of that was a huge amount of feedback to the authors of the draft into how they could change how they were doing it in DNS for the better, to make it work better with the protocol. And also the implementers were very impressed with the crypto that was defined in the paper. So this was a really, really nice collaboration between the academic authors of the draft and the implementers who actually want to get this out there. One small piece of work was looking at Doe. Myself, with reviews from a whole bunch of people, too many to put on here, I started looking at trying to define an anonymity profile to use with Doe so that clients who want to use that can look very standard and not stand out. And to help us understand whether this will work or not, we developed a very lightweight proxy that you can point a Doe client at, and it'll expose the headers that are being sent out on top of the Doe requests. Last slide is there was also a piece of work to take a rather old patch and port it to the latest version of NSD, and this therefore puts the capability to do DNS over TLS into an authoritative server. And this worked, it got tested, we've got some performance numbers, no real surprises, it just seems to work. And lastly, there was also work on implementing a a draft which is based around zone digests for integrity. And we had a bunch of people, and we had 2 new people, so welcome to them. Thank you.
Okay, next up, ESNI.
All right, hello everyone. So for those of you who may or not know, the SNI privacy problem has been something that's plagued TLS for a very long time now. We always just send this particular piece of information in the clear, basically revealing to the entire world where we're going. And so we've wanted for a very long time to encrypt this, and so this particular IETF, we wrote a draft and set out to actually do so. And the approach is pretty simple. Just shove some keys or some key shares, depending on the key shares in DNS, fetch them privately over DOE, mix them with your client hello key share, and use that to drive some keys to encrypt the SNI and then send that into an extension to the server. And so our plan was to simply implement that and test and make sure that it worked. And this was along with some various other people, Fastly, Cloudflare, Mozilla, and Apple, and various TLS libraries, particularly PicoTLS, NSS, and Boring SSL. And the results were pretty good. We got complete interop between all supported clients and servers. There are 2 servers set up right now that support this, that have fixed records containing these ESNI keys. We managed to get into Firefox, so in a branch somewhere in Firefox, you can actually go to these particular domains and connect with the SNI and get served the right certificate. And we're working on finishing up experimentation with Safari as well. Ta-da.
Okay, the DNSSD.
We did some work this weekend on DNS service discovery. Probably half the people in this room, they've heard of DNS service discovery, and you may think that's the thing to do with multicast DNS. That's link local multicast, and that's part of what it does. For a long time, it's also run over unicast, and in fact, that's what we're doing here at the IETF. If you tap the AirPrint button on your iPhone or your iPad, and you see the terminal room printer show up, that is DNS service discovery, but you're not in the terminal room. That's the other side of the building, up a couple of floors. So that works, but it requires the experienced IETF network operators to know the right records to put in the DNS server to configure that manually. So the DNS SD working group has been working on automating that process. This is important these days because there are wireless mesh networks where multicast is not very efficient. Enterprise Wi-Fi networks frequently disable multicast for the same reason that multicast is very wasteful on Wi-Fi, and home networks are getting more complicated. So it's becoming more common to have more than a single network segment in the home. These are the documents we're looking at. 6763 is the base service discovery specification. That defines how the client does the queries over unicast DNS. What we're adding is automating populating the namespace. Ted Lerman has been working on a relay, which is analogous to a DHCP BootP relay. At home, you may have a DHCP server on the network, but in an enterprise, it's common to have the DHCP server in the data center and lots of little BootP relay agents scattered around all the links in that enterprise. So taking that inspiration, Ted has been working on a similar thing for service discovery, where you can have a discovery proxy in the data center, and it in effect has remote virtual interfaces on various links around the organization. And Ted now has that running on OpenWRT and some Raspberry Pi boxes. He has it running on one of his boxes at home. So even though he is a long way from home, his Mac can still see his upstairs Canon printer, even though it's not remotely connected to his home network. Tom Pusateri has been working on the discovery proxy, and this weekend at the hackathon, he was working on adding the new service registration protocol, which is how, instead of passively observing services on the network that are using multicast, services can actively register with the directory. And we had a new person joining us this time, Tim Wattenberg, and he implemented the client side of the service registration protocol, which is derived from the DNS update protocol. So this is not a greenfield development. He implemented that in Python, tested that against Bind 9 with DNS update enabled, and his code is now in GitHub. The little screenshot there is showing I was looking on my web browser. This was in fact a remote screen sharing connection to my house in Santa Cruz in California. You may be able to see there, I've got 4 of my Access Network security cameras are showing up when Tim used the registration protocol to advertise another web service. That 5th one appeared on the list at my house in California. So that's what we've been doing this weekend. These are the people who are working on it, and it is Tim's 2nd time at an IETF meeting and 1st time at a hackathon. So welcome, Tim.
Okay, thank you much for that. Next up, I believe, is Ace, if I remember right. Yes.
Hello, my name is Ludwig. I am going to tell you about the work we did in the ACE project. So ACE is for authentication and authorization for constrained environments. So what we're trying to do in the working group is to define a profile of OAuth that is usable on devices and networks that have severe resource constraints. And we're now at the stage where we can try and have code talk to each other. And that's what we basically plan to do. So we had different implementations of these 2 drafts. And we wanted to get them to talk to each other. We had a interop test specification, which I wrote and thought was really detailed. Turns out you can never be detailed enough. It's like you can always get the key identifier wrong or whatever else you can find to shoot yourself in the foot. I'm going to get back to that. What we did was we got our implementations to talk to each other. You can see various repositories from our implementations that we had in place. Actually, all the SEI ones are the same implementation, but they split it up in different repositories for different functions. So in the course of the interop, we did a number of updates to these implementations because we discovered a lot of problems in the code. Luckily, we didn't discover new problems in the protocols, so looking good. We had some questions, though, mainly about key identifiers and how they are supposed to be handled. What we learned is, we can get the basic protocol interactions to work. We can get the different implementations to talk to each other on unconstrained devices. Dan here is still battling with the constraint implementation, which is magnitudes more difficult to get running. So we're all not envying him for that task. but he's getting forward, so we're hoping to be able to get the same protocol running on a constraint device soon as well. And another thing we learned in general actually is it would be nice if someone or IETF or whoever would gather material on how you do a successful interop, and perhaps have like a document with recommendations or tools or a template, like this is how you do a good interop specification, like how you specify different test cases, and this is typical errors people make. So if anyone feels like the need to do an extra good thing for IETF, I think starting this kind of work would be immensely helpful for future hackathons and people trying to do interops of new protocol drafts. So team members, we had Jim Schad, Grace Lewis, Sebastian Chevia, and Dan Kleinins. I hope I'm not mangling your names too much. I should have asked before. And myself. Jim and I, we have been at several IETFs. This is my second, well, 1.5 hackathon. Grace, Sebastian and Dan are visiting the first hackathon ever, and Sebastian and Dan are visiting the first IETF ever. So welcome. Thank you for joining us.
Okay. Okay, for the LP-WAN, MC coming up. And we'll go back and get the JMAP one next. Whoops.
Good afternoon. So this is about CHIC, the static context header compression for LP1. This is, I think, the third hackathon on this topic. So our goals are in general to provide an open source implementation of CHIC. The draft is listed here, and right now the draft is in version -16. Some changes have been made recently. The draft is entering its second working group last call. And so our goal was to advance the state of the code to reflect that -16 version. So mostly by reading, sharing our understanding of the draft, the last changes, and coding, making sure the code reflects the last version. So what got done, we had actually 2 newcomers at our table this time. So we educated them on what CHIC was about and little devices we're interested in, and the constraints and the cost of transmitting a few bits opposed to the cost of computing. And in return, they provided us with a fresh read and fresh review of the draft, which is always welcome because we get so much used to reading our own drafts. So this resulted in about a dozen notes on improving the draft, mostly editorial, stuff that we left from previous versions that were inconsistent, but also one which was actually functional, something we forgot to specify. Also, we updated a few contributors on the recent advances of the draft because they hadn't followed all the details of the discussions. So we updated the CHIC has 2 parts. One is a compression decompression, one is fragmentation reassembly. So we updated the fragmentation code as a repo in GitHub. And also we updated the compression part and especially implemented a network side because LP1 is putting an end device in a network. we improved the network side Python implementation. What we had learned last time at the 101 was that it takes a long time to get all these little devices and the LoRaWAN network working in this room. And we can easily waste a full day having everybody working with those little devices. So we knew that, so now we decided to have 3 versions of our code, 2 free targets, one being the full Python-free implementation, which is for computer server side. One is the PyCharm's MicroPython implementation, and one in between, which eases the transition between the two, is the Linux-based port of MicroPython, which allows anybody in the world with a computer to get acquainted with MicroPython, which we didn't have before. So as a wrap-up, we had 6 people locally around the table, contributing 1 remotely in Japan with 11 hours time difference. So he stayed awake until 4 a.m. local time to contribute to the group. And 2 among those were newcomers to the IETF and to the hackathon. And so we got the code advanced, but it's not finished, so we'll probably carry on working on it during this week and after that as well. Thank you.
Okay, we're going to go back and get the JMap one, which came in. I've only got the one slide here. We were a group of people kind of all working on our own thing. The JMap project is a replacement protocol for IMAP and for email. And so we have had a group that were working on a client in PHP for PHP webmail systems. We had a group working on the JMap tester, which is a test suite for server implementations. I was working on the JMap Perl Proxy, which proxies from JMap to IMAP, CalDAV, and CardDAV servers so that you can run your existing servers and run JMap on top of it. And we also did some work on the Saris IMAP server and found some inconsistencies in the spec, which we have pushed some change requests back for. We're meeting tomorrow afternoon if you want to come along and find out about it. And we'll keep working on all of these finished. That's all I've got. All right. Very efficient presentation. I like it. Okay, so next, MLS.
Hi, everyone. So message layer security is a new working group at the IETF about essentially securing group key exchange for asynchronous messaging. These drafts are very early on, and so this is that's just a disclaimer for the whole rest of the presentation here. So we wanted to basically get a common understanding of what these drafts embody. There's 2 different key exchange mechanisms, one using DB-Hellman, one using a public key mechanism. And we just wanted to figure out, can we compute the same trees? Can we compute the same stuff? And in fact, my group is back there still hacking away, and they just achieved a couple of common views of the same things using a bunch of different implementations. We have some new implementations. Everyone is sort of comfortable using different things, and they sort of want to use these in different applications down the line. So there's a C implementation. There's a JS Node one. There's a Java one that John Milliken's working on. Most of these people ported Richard Barnes's Node code to whatever they wanted. John didn't because he likes Java. What got done? a whole lot of just whiteboarding and just trying to figure out if we all have this common understanding of what the heck this stuff is and how it works. There are two sets of code here that are achieving some notion of a common view of the tree. There's a couple of trivial pull requests to the MLS drafts that we have live. What did we learn? It's hard to describe. We kind of better understand this stuff. The drafts are in an early state. We're in a better state to contribute to this kind of conversation, actually improve some of this code. I do think and I'm not sure how to word this, I'm not an expert in this stuff, but it sounds like we found some sort of sharing of the secret key that shouldn't have happened. And I think we've modified that by adding a nonce or something somewhere. Anyway, and so very early stuff. Come talk to us if you've been working on this stuff. I know there's a lot of draft authors out there that are working on other things. Here's the folks that were involved. One new IETF hackathon attendee, Nat Meisenberg, for being an architect. Thank you.
All right. Well, it's great to see the code coming in very early in the process with the learnings there. So good to see. All right. Kami project. Boom.
So, hello everyone. We've been working on the Kami project which is, dealing with Yang for constrained devices for this hackathon. And so, yeah, just to position where we are. Well, it is an addition to the Yang family. So, yeah, we have netconf and resconf, and Kami, we can say that it is a set of technologies. So there is a way. So bringing the Yang to ecosystem to constrained devices. So we have a technology to map Kami to CBOR, so efficient payload representation. And then we have how do we have the bindings to the co-op protocol. And something that we can call like a compressed IDs, but they're not really compressed. It's structured identifiers, so like numbers, so that we are actually able to send these identifiers over very, very, very constrained links. So that's on what we have been working on. What exists? Well, we have a couple of drafts that are working with items and that have been stable for some time now. We have a running example registry for these numbers that is out there, so you can go and you can play with your own Yang modules if you wish. And there has been an implementation. So I'm saying example implementation, but it really is a full implementation of a client and a server over the finterop platform. So in case you would like to do interop testing, we would strongly advise you to actually approach the finterop guys. It's really something very, very interesting, very powerful, that allows you to run all kind of interoperability tests. So this is the existing, and what we wanted to achieve during this hackathon is actually to provide some open source code. And we wanted to help people bootstrap their implementations, so provide examples of how to actually interact with the finterop implementation that is out there. And we wanted also to start the implementation of a full Python-based open source Kami client, and in the future Kami server. So the plan that we had is, well, first of all, getting started with finterop. Describe how we actually you run an finterop session, how we actually run an finterop session with Kami, and the baseline interactions with these implementations. So anyone can actually say, okay, well, I'm interested in Python implementation or a C or C++ or other. Well, I can do this to validate actually that it's actually working, and then move on to automated code generation based on YDK. So YDK is Yang development kit. So it's basically a way for people to develop their applications based on Yang. It's open source. So what got done? Well, we developed base examples on various operating systems, Linux and Mac, and I'm particularly proud about this one. We'll get back to this one later. And we actually clarified really, this helped us also dive into the how do you develop a Komai client and server, by the way. So basically it boils down to developing independently the Yang to CBOR mapping and the co-op bindings, which is actually a pretty great thing because this allows you to split your work, and there are no interdependencies at least. And that's actually a process that is compatible with commercial and even open source netconf RESTconf servers and clients. So you can get your existing netconf RESTconf server and you can add Komai pretty easily. And we actually identified also the steps necessary to do this. And we started our YDK-based Komai implementation. What we've learned is that it is not really the great thing to have over a sport event, the hackathon. Of course, the normal difficulties when you mix up Python with different versions, with Mac, with IPv6, and we needed to change libraries several times. Well, a very good pointer is to virtualize your hackathon environment. You can use Docker or stuff like this. And also YDK is user-friendly for the users, but for people that try to extend it, a little bit less so. And I'd like to thank our participants. So this is our first hackathon, actually, that we started. We had a person that was a remote participant. We had a first-timer. And we had also cross participation with the core Yang group, so that we really had very great discussions about this. And you have the docs that are on the Etherpad, and you have some code on GitHub. Thanks.
Hey, the docs. You are up next.
Hi, hello everyone. Kana Minjiska from Communications. Today I'd like to talk about the update of interoperability testing. Here's our hackathon plan. DOT is a DDoS open thread signaling, which is for a standardization of signaling for DDoS protection. So actually, we are attending the hackathon from IETF102-HACKATHON-2018 consecutively. Then at that time, there was only one implementation, but this time we have mainly two implementation, and then we did the first data channel interrupt. This is the phenomena. So what was done in the interrupt? There were two implementations. One is Godot, which is OSS running on AWS from my side. Then on the other side, one implementation from NCC Group, which is running on the production anti-DDoS box. Then as dot client and dot server each other talk over the signal channel and data channel. As I said, the data channel is the first time interoperability testing each other. Then on the data channel, we do the helping function to the DDoS mitigation action, like registration of clients and ACLs, and also capability discovery or something. Then here is the interrupt result. You may see that green cells are accomplishment in the IETF101, and blue cells are accomplishment in the IETF102. Then you may see that the test space is enhanced significantly. And as I said, the data channel is the first time, but the lower side is the testing over the data channel, and all of test was successful, and the found issues will be reported to the working group. And also we did the signal channel interrupt with the latest draft of student channel draft. Then here the takeaway. The core specification of dots is now mature enough, so we did the successful interop testing. Then several issues found, but that is not so significant, and those will be reported to the working group. So the implementation, one is OSS and one is proprietary, and also more implementations are welcome. And as a reference implementation, OSS code is available on GitHub, so please read and use this OSS. So wrap up, John Sharrow from NTC Group attended this hackathon remotely from London. I appreciate it, and that's it. Thank you very much.
Okay. A couple more, so Suit is up next. That's like your presentation.
So we worked on firmware updates for IoT devices as a continuation of a hackathon we did in London. And we also had one in Berlin roughly 1.5 months ago. This time, one of my coworkers worked on a hardware dedicated for our interoperability on hackathons, which you can see on the left-hand side, the multi microcontroller board with a separate flash and a secure element. And we tried to get this the code working on this new board. The goal was to generate this manifest, which is the metadata for the firmware plus the security wrapper, encode it in CBOR, sign it with COSI, and then verify it on the IoT device. And so for the generation, we used Python, but of course on the IoT device we used, on this board, we used C. This is our group actually over there. We had a couple of people who were the first time participants of the Suit Hackathon. We also had first timers in the IETF in red and some older guys, me and Jamie. What did we do? Since we had a couple of new folks working on this topic, we spent some time on setting up the development environment for this for the board, getting distributing the boards and getting everything working. We used Mbed OS as an operating system for the device. We successfully generated the manifest, encoded it, signed it, did all the keying stuff, and also wrote the parser for the verification of it on the device. We also produced a detailed write-up like last time, so we can actually memorize things till the next event, and which can be found here on this link. A couple of items we learned. During the activities, we managed to break a couple of the boards. That's obviously, we need to work on that. We also, it would be nicer to have a way to set up everything in a much faster way for first-timers, because there are lots of tools involved in the embedded development, and setting those up appropriately for different operating systems is a hassle. Using IDEs for debugging, specifically if it's more complicated crypto, would also be nice, but requires some work. And then we obviously struggled a little bit with the implementation, in this time with CBOR, last time with COSI, so we managed to deal with that in between the London IETF meeting and this meeting, but now we are at the issues with COSI libraries. And there's also some feedback for the draft work. Yeah, and finally, getting everything back together in a reasonable size for a bootloader is still going to be a challenge, but that's sort of left as an exercise for future hackathons and future work. And that's it. Thank you.
Right. Now we have a remote presentation. Calling in from Mauritius. Are you guys out there? Can you hear me? Can you say something?
Hello,
so we
Charles.
can hear you? Yes, we hear you. It's a little loud.
Okay,
a little
great.
bit of
Thanks.
feedback. Okay, I'll advance the slides for you. But yeah, we are getting some feedback. So I don't know if you need to be away from a mic a little bit or something.
So, hello everybody. Charles?
Okay.
Hello everybody, I'm Nitin from the Hackers.mu team. So our goals for the IETF102 Hackathon focus on two parts, application integration, and the other is interoperability. Charles, can you just move one slide further? Okay, great, thanks. So all participants are working remotely from Mauritius. On the application integration part, we had worked on the implementation of Draft 28 on upstream open source projects. For example, in the case of PHP, it is not possible to specify a TLS 1.3 connection only using the PHP curl library. So we had to make a PHP curl library TLS 1.3 compatible and test it using PHP code itself. As regards to the interoperability, there are some challenges to make TLS mirror boxes more compatible with real-world deployment. We had the challenges to make sure that all unit tests worked accordingly. So the application concerned. Can you just move one slide? So we have PHP, like I mentioned previously, it did not have its curl function support for TLS 1.3. So a pull request was sent to PHP. HTTP perf, which is a tool for measuring web performance, pull request sent. NRP, a tool to measure remote machine metrics. Mercurial, a mail was sent to the Mercurial mailing list. SOCAT, mail sent to the developer. And curl, it now has its middle box compatible with TLS 1.3 support. The good news is that we now have Nagios plugins and Git already merged. So on the interop side, we have been able to accomplish several interop tasks with several TLS features such as full handshake, resumption, and zero RTT. The libraries concerned are OpenSSL, Boring SSL, TLS Slide, -ng, Wolf SSL, and NSS. Well, interop is very important as different implementations can interact with each other thanks to Wireshark, which helped us a lot. So here are our participants. We welcome, these are our participants from the Hackers.mu team. Can you just move one more slide? So we also have our first time participants in the IETF TLS 1.3 hackathon. Our youngest participant is actually 15 years old. So all of them work on the TLS 1.3 except Vigish Ramdani, who made an amazing hacking on HTTP 451. So I included a few pictures of us during the IETF102 hackathon. So that's us. And can we just one more? So that's near our pool in Mauritius. So I would also like to thank Nick Sullivan from the TLS 1.3 dev team, Lorenzo and everyone from the Mythical team, Charles and Barry for facilitating the hackathon, and the open source developers who collaborated with us. So thank you everyone, and looking forward for the next hackathon.
Are there any presentations that I missed? Anyone without slides that had something to say about their project? Okay. You want the link, right?
All right, so there's the link again for voting. We'll give you maybe, what time is it now? 3:30. So we'll give you maybe 10 minutes to get your votes in. Again, please don't vote for your own project. Out of your peers, which other project best accomplished what you think we're here to accomplish? And I'll just shut up now for about 10 minutes. We'll let that sink in and get your votes in. And we'll see you in a few.
So I'll leave that up on the screen for those of you who need to get the link. Just one more reminder of a couple things. We have the Code Lounge that will be going on all week, Monday through Friday. I encourage you to use that space if it's helpful. You don't have to sign up. There is a sign-up sheet. The signing up is really just to help you coordinate with other people, so you can kind of put your name down, your project, and then everyone knows that you're planning to be there at specific times. Now, for the happy hour, the Hack Demo happy hour, that you do need to register, because we need to know how many people how many teams are going to be there, so we get the right number of tables, the right number of signs, and all of that. So I just see a show of hands. How many teams, if you can have one person from your team raise your hand if you're planning on demoing something tomorrow at the happy hour. 1, 2, any more? Okay, 3, yeah, so, okay, keep 4. So, again, it's just, it's a way for you to share what you've done, get some more feedback on what you've done, share it with more people. It'll be great to see some of these teams, you showing other people what you've done. It's also a real good way just to get the word out about the hackathon in general, what's going on here. It's really nice to see so many of you here, but there's obviously a lot more people who maybe have been intimidated or didn't quite understand the spirit of it, and showing your project there is a good way to get that word out.
All right, so how many of you think the hackathon is really useful and fun and accomplishes a lot? Clap, clap. All right. How many of you think Charles does a great job running this? Yeah. All right, thanks, Charles.
Well, thanks, Barry, and thank you to Barry as well for all he does with the hackathon. Okay, and we look forward to seeing how this experiment of you guys voting goes, and we'll give you a few more minutes to do that.
Okay, we're ready for results here. The votes have stopped coming in, so I think we're ready to do results. Thanks everybody for doing this, participating this way. I think this was a fun way to do it. I like the way it's worked out. We have a clear sorting out here. The number one group is the DNS, DNSSEC, DNS privacy group. That's got the most votes. And tied for second, we have Perk and Suit. So, you guys come up here and collect your prizes. And thanks again for participating, everyone.
You all have support.
Yeah. No, I didn't have
It's not just because we all need it.
Yeah.
Do you want something? Power bank? Or... Oh, power bank. How many? I should bring the board. Now I don't have it. Oh, yeah.
Guys, don't run away. So I want to do some
Group pictures. Group pictures.
the next. Yeah. One big happy. Three. Is there a photo op for this? All right.
Yes. Yeah.
It's pretty neat, right? Yeah. I mean, like how
First other, what do you call it?